Hey everybody, you just tuned in to What's Up with Giancarlo. Today we're looking at topic 8, lesson 7. Find volume of cylinders. I can use what I know about finding volumes of rectangular prisms to find the volume of a cylinder. The standard is MA.7.GR.2.3. Solve mathematical and real-world problems involving volume of right circular cylinders. All right, let's get started. All right, example 1. Relate volumes of rectangular prisms and cylinders. Jenna and Ricardo need to buy a tank that is large enough for 25 zebrafish. The tank needs to have a volume of 2,310 cubic inches. How can Jenna and Ricardo determine whether the cylindrical tank can hold the zebrafish? Well, that's a good question, math book. Let's get into it. Well, like you did to find the volume of a prism, fill the base of the cylinder with one layer of unit cubes and stack the layers to fill the cylinder. We're not going to do that. So we're going to apply the formula to find the volume of the cylinder. All right? So V equals capital BH, but capital B is just the base of a cylinder is a circle, so the area of the base is B. The capital B stands for the area of the base, is what that is. So capital B equals area of the base of the base. And there's one sneeze for the video, class. So um, you just plug it in. So volume equals capital BH, but we know that the B is actually the area of the base, which is pi r squared. So pi r squared, all right, times h. So now let's plug in the numbers. V equals, what is pi? 3.14. What is r? Well, we look at this. 24 is from one end of the circle all the way to the other end of the circle. That is a diameter, okay? So to find a radius, we have to cut that in half, okay? So right here, from the very center all the way to the left or all the way to the right, either one. So half of 24 would be 12. So 3.14 times 12 squared, and then times the height is 48. So let's keep working. 3.14 times, what's 12 squared? It is 144. 12 times 12 is 144 times 48. So now we do 3.14 times 144. So we get, I'm just going to move it over here. It should be up and down, but I don't have any more space. So V equals 452.16 times 48. To get this, I multiplied 3.14 times 144, okay? And then we just multiply those two. So 452.16 times 48 equals 21,703.68. And since it's volume and it's inches cubed. We always use cubed when it's volume, okay? So, can it fit? They need to have a volume of 2,310 cubic inches. We have, 2,310. We've got a volume of 21,000. So, yes, the cylindrical tank is large enough for the 25 zebrafish. Okay? This is our answer. Well, actually, our answer is yes, they can fit it, but this is our real answer that we worked for. All right? Okay, example 1, try it. The area of the base of the cylinder is 78.5 inches squared. What is the volume of this cylinder? I'm going to go ahead and pause. You can go ahead and pause it right here so you can work it out. All right. So V equals BH. What does the B stand for? The base of the area of the base. You're right. So what is the area of the base? What is this B that we plug in right here? V and V. So it says the area of the base of the cylinder is 78.5. So 78.5 goes here. And then times the height. Times the height. The height is 11. So we plug that in. Now we just multiply. 75. I lied. 78.5 times 11 equals, and the volume equals 863.5. Okay, so the volume of the cylinder is 863.5 cubic inches. If you got that right, give yourself a little pat on the back. And we're going to keep moving forward. On we go. Example 2. Find an unknown measure. The volume of the coconut water can is 300 milliliters, which is equal to 300 cubic centimeters. What is the height of the can? Use 3.14 for P and round your answer to the nearest tenth. So we have our formula. V equals capital BH. Okay? So we know the volume is 300, and that equals pi r squared. So pi r is half of 5.2, so 5.2 divided by 2, and that is 2.6. 2.6 squared, and then times the height that we don't know. We don't know the height. So now we got to work out the information that we do know. So 300 equals pi times, what is 2.6 times 2.6? It is calculator is having technical difficulties. It is 6.76 times the height. Now let's do pi, which is 3.14 times 6.76. And we get 21.2264 times the height. So now to get height all by itself, we have to, since it's multiplying, we have to divide both sides by 21.2264. 21.2264, and that gives us H equals 14.1. I know it's right here and right here, but I like working it out on my own. Okay? You got to stay honest, class. Got to stay honest. So the height of the can, all the way down here. Oh no. Is 14.1 cm. All right? Looking good, bruv. Okay. Example 3. Solve problems involving volume of a cylinder. Safety barrels are used on some highways to cushion cars on impact. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3.14 for pi. So we have to find the volume. We have to find the volume first. So the height is 1.2 and the diameter is 0.9. So V equals BH. V equals pi. I'll just do that. R squared times height. V equals pi. Half of 0.9 is 0.45. 0.45 squared times the height, 1.2. And then 0.45 times 0.45 is V equals pi times 0.2025 times 1.2. And then we multiply that times 3.14. V equals 0.6358 times 1.2, and then we multiply that by 1.2, and then we end up with our V. Okay, I don't know why they go to approximately here, but V is approximately 0.76302, and that would be meters cubed because that is um volume. So now it's 15 cubic meters of sand. This is how much we can fill in each one. So now we do 15 divided by 0.76302, and that is approximately 15 divided by 0.76. And it's 2 sneezes. Woo! Okay. 76302. And it is approximately, rounding to the nearest tenth, which they don't ask you to do, but they tell you to do, so whatever, or they do it, so 19.7, and you can't have 0.7 of a barrel, so we would say 19 altogether. Okay? Let's move on to the triad. How about that? All right. So, example 3, try it. Lynn is building a cylindrical planter with a base diameter of 15 inches. She has 5,000 cubic inches of soil to fill her planter. What is the height of the largest planter Lynn can build? So, this is not example 3. This is actually example 2. Okay? So, we're missing the height and we have to figure out the height. So, this is exactly what we did in example 2. Remember? We found the height and everything. Okay. So first things first, write the formula. V equals capital B H. And then V equals pi R squared H. Okay. So we have our volume. Okay. It is 5,000 equals pi, and then R, the diameter is 15, so the radius would be half of that, which is 7.5 squared times H. Okay, I don't know if I paused for 3 seconds, so you guys can work it out from here. Pause it. All right. So what we do here is, first thing, we do 7.5 squared, which is 7.5 times 7.5. And at that point, we get 5,000 equals pi times 56.25. times H. And then we multiply 56.25 times 3.14. And that gives us 5,000 equals 176.625 H. So now, how do we solve for H? We have to divide both sides by 176.625. 176.625. And that will leave us all alone with H because this makes 1, so it's 1H, but H. And then when we divide 5,000 by 176.625, we get approximately 28. So it is 28 inches for the largest planter Lynn can build. All right? Go ahead, write that down. Pause it if you want to write it down because I'm moving on. And here's the key concept, which is basically everything going over. Just following the formula for the volume of cylinders is how you do this whole lesson, okay? Thanks for tuning in. And remember, if you're watching the video, you're part of the class. See you next time, everybody.